Okay, this video is going to be the part 3 of the Unit 4 test review. Okay, in number 13 here it says that Stephen borrowed $325 to buy an electric scooter. The function f of x equals 325 minus 32.5x can be used to represent the amount of money Stephen owes on the loan, where x is the number of weeks that Stephen borrows towards the loan. Okay, describe the slope and the zero, or the x-intercept of the function. Okay, so let's think about the slope. Remember, when we talk about slope, we're referring to y equals mx plus b. All right, now, in this example, we see that Stephen has borrowed $325 and we are subtracting 3250 times x. X would be the number of weeks. That's our variable. What this is saying is that he borrowed that $325 and he's paying back $32.50 each week. So if we think about that on a graph, this is our x and y. He starts out here with $325. And the slope is negative because he begins to pay it back. He begins to pay off the loan at $32.50 a week. And then eventually he gets down here to the X-intercept, or the zero. Okay? So what you need to understand is what the slope means and what the X-intercept means. So again, in this specific equation, y was equal to 325, which was actually the y-intercept, minus the slope of 32.5x. So you need to understand that this minus 32.5 was what he was paying back. So the slope is what he's paying each week. And then the x-intercept is down here at 0, so he's been paying back the loan, and then finally out here at this number of weeks, he no longer owes any money, or he's paying nothing back because the loan has been paid off at this point. Okay, so this question 14 says that a correlation exists between the speed at which an automobile is driven and the amount of gasoline used by the automobile. Which statement best compares the contrast, association, and causation between the speed and amount of gasoline used by the automobile? Describe the relationship. So this relationship is actually both association and causation. Obviously, a car uses gasoline to drive, so they are directly associated. And the speed, as the car begins to speed up, it requires more gasoline, so it is actually a causation relationship. So in this example, you would have both association and causation. All right. Now, sometimes you can have association, but not causation. So you just need to be sure you read and pay attention to what you are, to the specific situation. Okay, this is number 15. You have a table here, and this problem, some will be similar on the test, but this is actually a review from a previous test. We had trouble with this equation, so we're going to take a look at it again. In this example, we have a number of soccer balls and the total cost. So you can see we have 9 soccer balls and a cost of $87.50, and 13 soccer balls at a cost of $117.50, and then 22 at $185. Now, this doesn't say that this is direct variation. So it doesn't say that you can divide $87.50 by 9 and get the constant of variation and then apply that to all the others. It's just listing a table, and it asks, what is the rate of change of the total cost in dollars with respect to the number of soccer balls ordered? Okay, so what we need to do is find the rate of change, which is the slope. Remember that the slope is the change in y over the change in x. Okay, the formula is actually y2 minus y1 divided by x2 minus x1. Now, I taught you that you could use the strategy of stack, slide, subtract to help you keep your numbers organized. So we need to use an x and y. But be sure that you realize that this first set is an x and y. So when x is 9, we had 8750. All right, and then when x was 13, we had 11750. So be sure that you set these up correctly. I think last time when we set these up, some of you just kind of mistakenly put 9 and 13 as the x and y, and 8750 as another pair of x and y. So be sure you recognize this is a this horizontal table. Okay, so we have 9 and 8750, 13 and 11750, and we're going to stack and slide and subtract. So we're going to subtract our y, or we're going to find the change in y by starting with the 8750 and subtracting 11750. And then down at the bottom, we're going to have our 9 minus 13. And when you work this out, you're going to get negative 30 for the change in y over negative 4 for the change in x. And then when you work that out, you're going to get $7.50. So the rate of change is $7.50. Okay, so in this number 16, it says write a linear equation in two variables that passes through the point 2, 5 and negative 1, 11. Okay, so we have learned that we can write an equation using point-slope form when we have a point and a slope. However, in this one, we're not given a slope, but we are given 2 points. Okay, so in order to find the 2 points, we're going to need the slope. And remember that the slope is the change in y over the change in x. Okay, one of the strategies we used, again, just like the last problem, is to use stack, slide, subtract. So we can take our 2 points in any order. I'm going to start with this one. I'm just going to put the negative 1 and the 11 in the x and y column. And then I'm going to do the second one, 2, 5. So put the 2 in the x, the 5 with the 11. Now that I've stacked those, I'm going to slide them into place and subtract. So what I end up with is subtracting 11 minus 5. And then in the denominator, I end up with a negative 1 minus 2. Okay. When we work these out, we end up with 6 over negative 3. And of course, 6 over negative 3 is going to be negative 2. So now what we know is that we have a slope of negative 2. So when we use our formula, or our point slope form, we have y minus 1 equals m times x minus x1. All right, so then we just plug in. Of course, this m value is going to replace the m. So the negative 2 will replace the m, and then we're just going to pick one of these points. All right, so I'll use the 2 and the 5. Notice they're both positive, and when we plug them in here, basically they become the opposite, because we're going to be subtracting a 5 and we're going to be subtracting a 2. So when we write it out, it's going to end up looking like the opposite. So y minus 5 equals negative 2 times x minus 2. Then this could possibly be your answer. If your answer is asked for point slope form, that's your answer. If it needs it in slope intercept form, then we have to work it out. All right. So to work it out, we need to multiply the slope of negative 2 times both terms in the parentheses. So we're going to end up with y minus 5 equals negative 2x for negative 2 times x, and then negative 2 times negative 2 is plus 4. So we would end up with plus 4 here. Now this is an equation that we can put in y because mx plus b form if we solve for y to get y by itself, we have to get rid of this minus 5, which we would do that by adding 5 to the left side. So we also add 5 to the right side. And now you'll see that we have y equals negative 2x, and then 4 plus 5 is 9. So that's your answer there. Y equals negative 2x plus 9 if you're putting it in slope-intercept form. So remember, we have point slope form, which is this one, and then we also have slope-intercept form, which is this one. Okay. Okay, let's take a look at this problem shown as number 17. This might be a little hard to read, but this shows a scatter plot that shows the monthly high temperatures for Austin, Texas in degrees Fahrenheit over a 12-month period. Okay, so you can see the months here going by 1, of course, showing all 12 months, and then you see the temperature. Now it breaks here from 0, and it starts at 85, and then it starts going up by by 2, 85, 87, 89, 91, and so on. Okay, but what it says is which function best models this data. Okay, so here is the data. Now this is a scatter plot, so you don't see a line for an equation. You have some outliers here, but what you have to do in order to identify the function is to find a slope and intercept. Well, we're going to draw the line of best fit that goes right through the middle of the main cluster of data. Okay, so I'm going to take this line over here, I think, and let's show this line about right here. Okay, now this line is going to show, this is called the line of best fit. I've drawn a line as best as I can, what appears to be like right through the middle. Okay, and then when you look down at our answers here, one of the things that should jump out to you is the Y-intercept. Okay, so you can see that it's in between 89 and 93, or it's in between 89 and 91. So it looks like it's right around 90. And you can see that your Y-intercepts only have one that is 90. Okay, so that's obviously a clue that that's likely our answer. You can also see that 2 of these answers have a negative slope. So like on a multiple choice question similar to this, obviously this is not a negative data set. Okay, this is a positive correlation. Okay, so we're looking for the slope and the Y-intercept. And if you do identify the slope, then you see, of course, that we have like the Y-intercept here, and then the next point is maybe right here. So it does look like we're going up, let's see, from 90 to 95. So that's up 5, and then we're going over 2. So if we have a slope of 5 over 2, that it actually equals 2.5. So yeah, you can see down here that our slope is 2.5x, and that we started at 90. So that's how you can identify a function from this set of data. Now this is a positive correlation. It looks to be probably more on the weak side. They're not. Well, they're somewhat close together, but we have quite a few outliers here. So anyways, that's how you can identify the function. And that is the end of the review.